going to take a look at work and energy. So when you apply force to an object, energy is expended, and that's called work. Let's take a look at the units to review so that we remember. So we're going to take a look at two different systems, the metric system and the British system. Okay, so the units of force in the metric system is the Newton. Now a Newton is a kilogram meter per second squared. And in the British system we have the pound. So the formula for work is simply the force times the distance. Now here this is assuming that force is going to be constant. So that's important for this formula to work. Okay, so then that means that the units for work are going to be, in the metric system, it's going to be the Newton meter, also known as the joule. And in the British system, it's simply called the foot-pound. Okay, so having these units down are really important to being able to do work problems effectively. So let's take a look at a simple example. Okay, so here we want to find how much work is expended to lift 50 pounds 5 feet in the air, and then after that we're going to do a metric system one, 50 kilograms 5 meters in the air. So we've got our little guy here, or gal, and he's going to lift this 50-pound weight up 5 feet in the air. So the work is equal to the force times the distance. So the force is simply 50 pounds, and the distance is 5 feet in the air, and so then the work is 250 foot-pounds. And that's it. Now, key thing to keep in mind is that the force is constant throughout as this little guy is lifting it. So that's important to remember. Now, the second part is the only difference here is that if you're in the metric system, you know, the formula is the same, but the force isn't built in. So this guy, 50 kilograms, is the mass. You then have to multiply this guy times the gravity. Which we know is 9.8 meters per second squared. So once we do that, then we get sorry, I forgot. We have to multiply that. So this right here, this is the this part right here is the force, and then of course times the distance, which is 5 meters. So if we do that, then we get 2,450 Newton meters, or also called joules. And that's it. So when the force is constant, that's all you have to do. Okay, so the big question now is what happens if the force is not constant? So here we've got an example of a container full of water. And so we're assuming it's full of water. And we want to calculate the work necessary to take this water up and out of the container. Now, the issue is that the force on this water isn't constant throughout because the work needed to take the water out from the top part of the tank is, of course, much less than the work needed to take the water out of the bottom of the tank. Okay, so let's talk a little bit, before we sort of dive in, let's talk about the idea. This is very, very, very important to understand the idea. The idea is that you take a random, not a random, but we're going to take them sequentially, but you take a slab of water of thickness. This slab of water is going to have a thickness delta y. Here I've got this slab of water. And so this slab of water that's in here, I'm going to put it over here. So I've got a slab of water. So the idea again is to find the force, the gravitational force acting on the slab. Because then once you do that, then you can calculate, once you calculate the force, you can calculate the work on the slab to move it from where it's located out of the tank. And we're going to call this y because that part is going to be variable. So how exactly are we going to do that? Well, it's a process, and you need to keep in mind the units. So since we're in the metric system, remember that the units of force is the Newton. So the unit of force is the Newton, which is a kilogram meter per second squared. So that's what we're working towards. So the meters per second squared, that's gravity. So we know that. So we're looking to get the mass. Okay. So the idea is that we're going to go from the volume of the slab, this slab right here, which we can find by finding the area of the base times the height, which is delta y. So this, in this case, the area of the base is fixed, 2 meters. And then once we do that, once we find the volume, we can find the mass by multiplying the volume times the density. So we multiply the volume times the density to get the mass, and then once we have the mass, that's going to be the kilograms. Then we can get the force by multiplying by gravity. Okay. So let's write this down, and then I'm going to show you guys how we actually build the integral. And so then we multiply the force times the distance. Oh, sorry. Looking for the right color here. Times the distance. And that's going to give us the work. Okay, so let's get to it. So the first thing we want to do is we're going to find the volume, like we said. Okay, so the volume is the area times the thickness of the slab. Let's go up to take a look at the picture again. So we've got our slab right there. So this is equal to 2 meters times 2 meters. It's really important that you put the units in. And then times delta y meters. And this is going to give us 4 delta y cubic meters. Once we have that, we're going to multiply times the density to get the mass. So volume times density, which is going to equal to volume, which is 4 delta y cubic meters, times density of water, which we were given earlier, 1,000 kilograms per meter cubed. Notice the meters cancel, and so we're left with 4,000 delta y kilograms. Then the next step is to multiply by the gravity to get the force. So the force is going to equal to the mass, which we just found, 4,000 delta y kilograms, times the gravity, since we're in the metric system, 9.8 meters per second squared. And this is 39,200 delta y kilogram meter per second squared, which is the same thing as a Newton. Okay, so now here comes the good stuff.